As we take a look at the walker falling from a bridge, we can split this motion into two events. Event 1 is when the walker is falling. Event 2 is when the walker is at rest at the bottom of the cord after falling.
Let's make an interaction diagram and a force diagram for the two events. In the first event, the walker is in free fall motion, so the only force acting on him is gravity. In the second event, the walker is at rest but still dangling from the cord. If they are at rest, it means they are following Newton's first law, inertia. Therefore, the vertical forces are balanced. Looking at the kinematics, we can view this motion as a free fall. The walker is falling in the same direction as the acceleration of gravity, so the walker speeds up. In the motion diagram, the walker is falling down while accelerating, so the dots spread further apart per time interval. In the position time graph, the walker's position is reaching closer to the origin, which in this case is the bottom of the bridge, as time goes, and they are going in the negative direction, so the line should look like half of an upside down U.
In the velocity time graph, the velocity is increasing in the negative direction as time passes, so the line should be linear. In event 2, the walker is at rest, so the velocity is 0. The acceleration time graph shows that the acceleration of gravity is constant and going in the negative direction. In event 2, there is no velocity and no acceleration. Now let's look at the situation with actual values. First, we will find the net force by using the force of gravity equation, assuming the walker is 80 kilograms. Next, we will find the acceleration by using the F net equals mass times acceleration formula. As you can see, using the net force formula, the acceleration is the same value as the gravitational field strength that we had used in the previous calculation. This proves that this motion is a free fall motion.
What if the bridge was 216 meters high?
Aw, you walkers don't know anything. No wonder you hunt brains. The dynamics will remain the same regardless of the height. However, your kinematic motion will be affected.
If we use the acceleration we had obtained earlier, which is also the same acceleration of gravity, and we use the vertical displacement of negative 216 meters and the initial velocity of 0 meters per second, we can find the rest of the values by using the Big Five equations.
That's all for today, walkers. Stay tuned for episode 2, Zombies on the Run.